So I started out with a frequency sweep, and I found out that these large pulses, let me get my pointer here. This noise here is picked up by this whole scheme of metal, okay? These large sparks here, large spikes here, are what I'm driving at. That's my those are my pulses coming through. So what I found out, it started off, I saw it first at 91.8 kilohertz. These guys appeared. And then every increment of 9. And as I changed the frequencies from 9, 18, 27, 36K, I take that back, 91K. Start out 91K. Now I'm up to 366K, and they show up again. So if I crank this up to the next division of 9, which would be 45, these guys will show up. So you'll see as I crank up past the frequency I'm at now, 366K, these guys here will, except for the center one, the rest of these will disappear. As I get into the other multiple of the 91K, you'll see that they reappear. See, they're gone. And they'll stay gone. But you can see there's areas of frequencies where the noise actually is picked up better. So that's 414K. And even though at some frequencies these taller spikes will show up, they will be different amplitudes. But as we get to the multiple of 91K, you'll see that they're all equal. There. 458K, so that's 45. So it's 5 times 9. So I found the operating range of this coupled setup that I have. I'm driving the top horizontal run, it's 2 turns, and then I'm picking it up on the vertical overrep. And those are 2 separate channels also. I'm sorry, not also. This is 2 turns on the top run, and these are 90-degree coupled, these 2 channels here are 90-degree coupled, and I'm only reading 1 at the moment. So what I'm going to do is try to find the multiple of the 91K and see which frequency these are more stable at. I believe it's 91K because that's where I first started seeing these appear. And if it was anything shorter than that, these would appear in different ranges of the frequencies generator coming in. And it's been all increments of 91K, so I'm pretty sure what I found. See, the scope's not fast enough, but the triggering is not fast enough on the scope, which is too bad. I'd love to get a better picture of it. Okay. So I believe this is setting at 91.8K base frequency. And I'll travel into the next test with that parameter, and see what the other one, the other channel does here, and then start manipulating the connections across these center toroids to see what I can get. But this looks pretty promising. I'm not sure. I'm not sure if the toroids are set up in bucking mode now or not. I don't believe they are, but I can swap that out also. Either the two toroids are fired I'm sorry, not the two toroids, but 2 coils per each toroid fired this way or that way. I'll manipulate that next. But the goal was to find this on the big ring, and that's what I've done so far. So that's quite helpful, because I thought it was going to be a daunting task running through all kinds of frequencies and minute steps with my frequency generator, and then have to watch the scope to see what's going on. But I can use these spikes. The rest of this noise comes from the environment. Fluorescent lights, heater coming on, CFLs over on the other side of the room there. And I can fluctuate this noise by manipulating those other hazards. But this looks promising. So, and if I put my arm across them, you can see the noise gets higher. Taller, and the spikes get a little taller. So that's all for now. That's what I've got. Oh, these are 130 millivolts amplitude, big